Hello everyone and welcome to today's episode in which we'll be looking at vector geometry. So we're getting this from a 2017 paper 2 and it says in the diagram below OP, vector OP is equals to P, vector OQ is equals to 4Q and the ratio of Px to Xq is equals to 1 to 2. So we are required to express in terms of P and Q the distance PQ. So now our first question will be vector PQ equals to PQ we found by from P will come to O will go to Q. So PQ equals to PO plus OQ. So now vector PQ is equals to, remember that OP is positive, meaning PO will be negative. This will be negative 2 vector P plus OQ is equals to 4Q. So it is important to start with the positive part. Therefore, vector PQ is equals to 4Q minus 2P. This is our solution for question A. So going to question B, which says find vector Px. So to find vector Px, we are simply going to use the ratio given in the question. They are saying Px to Xq is equals to 1 to 2, meaning that the total number of units here are 3. So for Px alone is 1. So this is equals to 1 over total units 3 multiplied by the total vector, which is Pq. So it will be 1 over 3 multiplied by vector Pq. So Px is equals to 1 over 3 multiplied by PQ is what is here, 4 vector Q minus 2 vector P. So therefore, Px is equals to 4 over 3Q minus 2 over 3P. This is our solution for the second question. Going to question C, which says find vector OX. So to find OX, we're going to use the root for OP then PX. So OX is equals to OP plus PX. So vector OX is equals to OP will be positive 2P plus PX is what we're finding here, which is 4 over 3Q minus 2 over 3 vector P. So looking at what we have here, we have two like terms, the PPs. So we are going to work them out to add them. So that will be 2P minus 2 over 3P. This is over 1. LCM is 3. We're going to have 6P minus 2P. So this will give us 4 over 3 vector P. Therefore, OX is equals to 4 over 3 vector P plus 4 over 3 vector Q. So this is the solution for OX. Now, coming to a question which says, that is question 2, which says given that vector OC is equals to H vector OX, show that vector CQ is equals to this. So now, whenever you are proving any question, the other way of saying this is, they are simply telling you to say, can you find vector CQ? And while is finding vector CQ, use a root which will have OC. So we should first find OC. So OC will be equals to H OX. So now OC will be equals to H open the bracket. OX is what we are finding there. So this will give us 4 over 3P plus 4 over 3Q. So, therefore, vector OC is equals to 4H over 3P plus 4H over 3Q. So now, this is our vector OC. So now, because OC has been found, then now we can find CQ. So to find the CQ equals to, CQ should be found using a root which has OC. So from C to Q, will come to O, then go to Q. So CQ will go to CO then plus OQ, like that. So now CQ, vector CQ is equals to CO is the opposite of OC, meaning this would be the negative direction. Negative, open bracket, OC is 4H over 3P plus 4H over 3Q, close. Then plus OQ, which is 4Q, like that. So now we expand. So vector CQ is equals to negative 4H over 3P, negative 4H over 3Q, then plus 4Q, like that. So after that, we simply arrange this and make it look like this. So remember, this is Q and this is Q. We can't add them all or subtract them because this one here has an H, which is a constant. So now looking at what we have here, the part for P is at the end. So meaning this should go there and this should come in. So then we have CQ, vector CQ is equals to 4Q minus 4H over 3Q minus 4H over 3P. So at this point we will simply subtract this part because in here and in there we have got like terms. And looking at what we have here, we have what we call the 4. 4 and Q are common. Therefore, when we're factorizing a vector, if a number and a letter are common, a number should be in front of the brackets and a letter should be behind. So because 4Q is common here, therefore CQ will be equals to 4 is common. We open and close bracket like this, then we put the Q at the end here. So we divide now 4Q into 4Q will be 1 minus 4Q into this part, we're going to remain with H over 3. So this will be H over 3. Then we will subtract 4H over 3 vector P. So when you compare this part and this part, they are exactly the same. Therefore, this has been shown as shown. So this is our solution for the last question. So remember to consider subscribing if you're here for the first time and hit the bell for new videos. See you next time.